We have in the industry open source vision libraries like OpenCV, which are awesome libraries, very extensive functionality, but they are just a big body of open source. It's actually quite difficult to figure out how to accelerate such a library, so they end up typically running on the CPU and not taking advantage of the acceleration capability of the hardware. To address that problem, Kronos has just started a new working group which is temporarily called CVHAL, Computer Vision Hardware Acceleration Layer. We'll think of a better name. But the idea is we're going to figure out which are the key vision operations that we need to enable the hardware community to put that into accelerated hardware and to enable applications or libraries like OpenCV or other libraries to tap into that highly accelerated vision functionality. So, taking all these apps together, what are the processing steps that we need for augmented reality, and can we do it all in open standards now? Are we there yet? So, well, let's start. The camera, we need to do camera control, probably quite sophisticated camera control, and low-level image processing close to the sensor. Mwc Ar4 provides that functionality. We need to tap off the video stream into a tracking subsystem. We can use CVHAL and OpenCL to accelerate vision tracking. We need to bring in the other sensors and fuse them together into a coherent sensor stream to the application. That's the domain of stream input. We have the 3D rendering that's actually going to reach the user. You, of course, can use OpenGL ES. You can also use OpenGL ES for the composition because it's being fed the video stream very efficiently through EGL streams. And finally, we have the audio rendering to go alongside the graphics rendering using OpenSLES. So we're finally there. We can put a logo on each of these processing steps. Some of these are still in being built by the Kronos working groups, but you can see that we're actually getting very close now to being able to build a totally accelerated AR flow pipeline using non-proprietary portable APIs that we hope that many of the silicon vendors are going to implement. So having these APIs is great, but if they don't actually ship in real operating systems, they're not much use to anybody. The good news is that many operating systems, including Android, which is by many measures one of the key adopted OSs, are beginning to adopt these APIs. So OpenGL ES has been shipping in Android since 2.2. OpenSLES has been shipping in Android since 2.3. Mwc Ar4 has been shipping in Ice Cream Sandwich, that's Android 4.0. EGL has been there for a long time, kind of hidden under the covers, but increasingly it's going to be exposed to the developer directly, particularly with EGL streams. The rest of the APIs, not yet adopted by Android, but we hope that Google will continue to adopt them. And in the meantime, the flexibility of the NDK in Android lets OEMs ship these open standard APIs as an extended part of the NDK. They're cross-platform, non-proprietary APIs, so we can hope that many of the silicon vendors will provide the same extensions, and we can make a good case to people once we prove the value of these APIs that they should consider bringing them into the NDK. Finally, before I break, we have HTML5. Low power silicon, increasingly powerful, means that the more and more devices are going to be multimedia, graphics, and even augmented reality capable. Different operating systems, different form factors. HTML5 does have the chance of being one of the first truly adopted cross-platform, cross-OS programming frameworks. But if we're going to really use HTML5 to develop exciting apps like augmented reality, we need much more than just more HTML. We need all the stuff we've just been talking about. We need multi-core CPUs, we need rich accelerated 3D, we need GPU compute, vision processing, sensor fusion processing. How is the web community going to get all of that functionality quickly into HTML5? Well, One way is to not reinvent the wheel. It is to leverage the work that we've already been doing in the native API space and simply begin to lift up that functionality into JavaScript for web developers. We already have one first API, which is WebGL. Many of you might have heard of it. It's basically a JavaScript binding into OpenGL-ES. Now you can declare a 3D context for the canvas tag and use OpenGL commands to generate 3D graphics. Already getting pretty widely deployed and a lot of innovation happening in the web space. We actually have WebCL, which is a closely related sibling to WebGL, which is a JavaScript binding into OpenCL for parallel compute. We have Web Audio, which is a Google initiative for advanced web audio, and we're working with Google to see how we can accelerate web audio over OpenMax. Now, there are other potential ideas. These yellow boxes are ideas and stuff we're beginning to discuss with the web community. Better camera control and image processing. Perhaps we could do a WebMax, a binding into OpenMax. We need to do vision processing in the browser, perhaps WebVL for vision library, and sensor fusion. We can begin to leverage the work we're doing with stream input. So where are we now? We started with the hype cycle. I think we can actually begin to turn the hype into real adoption. How is this really going to start rolling out? I think you might find that industrial applications where people are willing to take it like a tablet and to use it in industrial and manufacturing situations where real money is at stake, and we can today save people real money by using augmented reality technologies. I think we're going to see those applications really start shipping today. My personal opinion is that in the consumer space, we're going to need wearable displays, which are getting closer to really ignite augmented reality in a big way. I think you're going to find that augmented reality perhaps isn't just an application, it's a technology that begins to get bolted in and used in many, many different types of applications throughout the industry. So, in summary, hopefully convinced you a little bit that the silicon guys are doing diligent work. These platforms are becoming AR capable, and you're going to see more from the next few presentations about real products shipping in the market today that are going to bring AR to a user near you any moment now. And it's going to change how we interact with everything. Once these devices can sense their environment and their user and generate useful and compelling information that's merged with the environmental information, it's going to be such a useful capability, there's no reason it's not going to be pervasive. So we're going to have the silicon community taking this first step, putting these technology building blocks in place. The industrial applications could be one of the first beachheads, but there's really an enormous scope for innovation, differentiation in the consumer space, and this is all going to be happening over the next couple of years, I believe, and the presentations you'll see hopefully will reinforce that. And then finally, my sales pitch for Kronos. We are driving these open standards. We would love your feedback if you're a developer. Don't be shy. Tell us what's working, not working. We have forums on the Kronos website. Please let us know what you think and whether we're solving your problems. If you're interested enough to actually have a voice in how these application APIs are developed and what direction they should go, please consider joining the Kronos group and getting a voice and a vote. Your input will be very welcome. Thank you very much.